Now let us look at the problems on differential equations. Okay, as we know that differential equations are of the form that is an dny by d xn plus an minus 1 dn minus 1 y dx to the power of n minus 1. Okay, and a2 d square y by dx square plus a1 dy by dx plus a naught y is equal to f of x. Okay, where you have an minus 1, a2, a1, a naught are and the function f of x are constants or functions of x only. Okay, and we where we denote d as d by dx. Okay, and d square as d square by dx square, and dn as dn by dxn. Now let us solve a few problems. Suppose if you have the function of a differential equation to find the general solution of an ordinary differential equation, f of d of y is equal to 0, then we have only the complementary function, which is represented as yc. And suppose if we have the function which is f of d of y is equal to f of x. Now this has the complementary function as well as the particular integral, that is yp. Okay, let us solve a few problems based on this. Let us solve the differential equation, that is d square y by dx square minus 2 dy by dx minus 3y is equal to 0. Now the given equation, which can be written as d square y minus 2 dy minus 3y is equal to 0, or d square minus 2d minus 3 into y is equal to 0. And this is a second order differential equation. Okay, and we will be having two solutions for this. Okay, the complementary version. Now the auxiliary equation corresponding to this is m square minus 2m minus 3 is equal to 0. Okay, so which has got the solution since it is a quadratic equation. Okay, so this is 3m plus m minus 3 is equal to 0, or m minus 3 plus m minus 3 is equal to 0. So this will be m plus 1 and m minus 3 is equal to 0, where the roots are real and distinct. So this is minus 1 or 3. Okay. And therefore the complementary function yc is c1 e to the power of minus x plus c2 e to the power of 3x. And the general solution of the differential equation will be y is equal to c1 e to the power of minus x plus c2 e to the power of 3x. since this the function here, which is f of t of y is equal to 0, which is a homogeneous equation. Let us solve another problem. That is d cube y by dx cube minus 6 d square y by dx square plus 11 dy by dx minus 6y is equal to 0. Okay. Now, which can be written as d square d cube y minus 6 d square y plus 11 dy minus 6y is equal to 0, or d cube minus 6d square plus 11d minus 6 into y is equal to 0. Now, the auxiliary equation is m cube, which is f of t of y is equal to 0, which is a homogeneous equation. Now, the auxiliary equation will be m cube minus 6m square plus 11m minus 6 is equal to 0. Now suppose we take m as 1. Okay, so it satisfies the equation which is equal to 0. So we got the root as 1. Let us find the other roots. Now let us use synthetic division to find the other roots here. So m as 1. So 1, the coefficients are 1 minus 6, okay, 11 minus 6, right? Now since this will be 0, okay, so 1 multiplied 1 will be 1, and add 1 we get 1. Okay, so the result of this 1 multiplying 1 is 1. Okay, when you add, we get as minus 5 multiply 1. Okay, we get this as minus 5. You add this, and this is 6. Yeah, multiply 6, so this will be 0. So the corresponding equation, quadratic equation, we get as m square minus 5m plus 6 is equal to 0, or m square as minus 2m minus 3m plus 6 is equal to 0, or m as m minus 2 minus 3 m minus 2 is equal to 0, or m minus 3 and m minus 2 is equal to 0. Okay, so we got the roots here as m as 1, 2 and 3. Yeah, and the complementary function yc is equal to c1 e to the power of x, c2 e to the power of 2x, and c3 e to the power of 3x. And the corresponding general solution is y is equal to c1 e to the power of x, c2 to the power of 2x, and c3 e to the power of 3x. Yeah. Let us solve another problem. Now this is d power 4 y by dx power 4 plus 4d cube y by dx cube minus 5d square y by dx square minus 336 dy by dx minus 36y is equal to 0. Okay, now this can be written as d power 4 plus 4d cube, yeah, minus 5d squared minus 36d minus 36 into y is equal to 0. Okay, and the corresponding auxiliary equation is m power 4 plus 4m cube minus 5m squared minus 36m minus 36, okay, which is equal to 0. Now this is f of t into y is equal to 0. Now the one of the roots would be m, which is minus 2. Okay, so this is coefficient is 1, 4 minus 5 minus 36 minus 36, right? Coefficients of the above equation. Okay, now put 0 here. Okay, so add this, so you get 1, multiply this, minus 2, add this again, this is 2, and again multiply, minus 2, minus 4, right? This is minus 9, multiplying it, so you get 18, and this is minus 18. Okay, and this is 36. Okay, the result is 0. So you get equation as m cube plus 2m square minus 9m minus 18 is equal to 0. Now again we got this as m as minus 2. So the coefficient of the above cubic equation, which is 1, 2 minus 9 minus 18. Okay, and again putting 0 corresponding to that is 0, add 1 and multiply to this as minus 2, adding 0, this is 0, multiplying, this is minus 9, and this is plus 18, again this is 0. Now we got the roots as m, which is minus 2 and minus 2, and the equation m square minus 9 is equal to 0, or m as plus or minus 3. Okay, so therefore we got the roots as minus 2, minus 2, minus 3, and 3. Since we got the same roots, which is minus 2, so the complementary function, which is c1 plus c2x e to the power of minus 2x, okay, plus c3 e to the power of minus 3x, c4 e to the power of 3x, okay, and the general solution will be y is c1 plus c2x e to the power of minus 2x, c3 e to the power of minus 3x, plus c4 e to the power of 3x. Okay, so this will be the solution, the given differential equation.